Hi everybody, this is Teacher Yong Lam and welcome to the explanation video for P3 HAL Math Mock Test 4. Right, so we can see that in this distribution below, there are some questions who has an accuracy rate lower than 50%. Most of it are actually related to counting or enumeration problems. Right, so we'll be looking through these problems together and I'll walk through some of the key concepts, key tips and tricks, right, when going through these counting problems. Also, there are some word problems as well. I'll be going through them. Okay, so with that, let's take a look at the first question, which is a enumeration or addition and multiplication principle question, right? So Gemma is given four number cards as shown below, right? So by the word number cards, it suggests that I only have these four digits, or rather these four cards available, right? I cannot repeat them. For example, I must use 1, 3, 1, 7, and 2 2s, right? I cannot have, like, for example, 3 3 7 7, cannot, right? So she wants to use these four number cards to form four-digit numbers. So how many possible four-digit numbers can she form using these cards? So I have four cards, so I must use these four cards to form the four-digit numbers. Okay, so I will introduce two methods to do this. The first way is enumeration, right? Or in other words, listing. Okay, so some of you probably have learned of this method called the dictionary arrangement method, right? So we are simply going to list things out in order from small to big, right? We have four digits, so let's start by choosing the smallest digit for the highest place value, right? For example, what if I choose 2 as my thousands digit, right? So 2, what? After I selected 2, the remaining digits that I can use is 2, 3, and 7, right? So then I can just write down the numbers in order, right? 2, 2, 3, 7. Then we try to keep the highest place values constant, right? While swapping the cuts or the digits at the lower place values. So after 2, 2, 3, 7, the next number I can form will be 2, 2, 7, 3. Right. So I'm swapping the 3 and the 7. Then we move on to 2, 3. And what? Right. I still keep the thousands digit while I move on to the next hundreds digit. So 2, 3, 2, 7, 2, 3, 7, 2. Right. Pay attention to what are the digits left after you selected the first two digits. Okay. Now moving on, we can still use 2 as a thousands digit, but now I have to use 7 as my hundreds. Then we follow the order, right? 2, 3 is follow, then 2, 7, 3, 2. Up till now, I have selected, right, 6 such four-digit numbers. And it seems like we have finished listing all possibilities where 2 is the thousands place. So I will move on to the next possible scenario. Right, now you might think, Teacher Yonglap, can I choose the other 2 as my thousands place? Cannot, right? Because the two digits are identical. 2 and 2 identical, right? So I cannot consider another 2, right, as the thousands place because they will give me the same numbers. So the next consideration is to pick 3 as my thousands place, right? If 3 is the digit at the thousands place, I will be left with which digits, right? 3 is gone. I am left with 2, 2, 7. Right. So in this case, you might think, is there like six numbers that we can form? Right. Previously, we also have 6. But if you list in order, you will get 3, 2, 2, 7. Then the next one will be 3, 2, 7, 2. And these are all the cases where I have 2 at the hundreds place. Then moving on, I will have 3, 7 at the hundreds place. And then the remaining two twos at the tens and ones. Now you might think, Teacher Yonglam, can I swap the two twos and get a different number? No, right? Because they are identical digits. Swapping the order will still give me the same four-digit number. Okay, so in that case, that will be the case where 3 is at the thousands place. The remaining case will be 7 at the thousands place, right? Then the digits left that I can choose from are 2, 2, and 3. Similarly, right, I can start with 7, 2, 2, 3. Then 7, 2, 3, 2. Right, and finally, 7, if I put 3 at the hundreds place, then it has to be 7, 3, 2, 2. Okay, with that, we have found all the four-digit numbers. There are actually 12 of them in total. Now, this is the first way of doing this using enumeration or listing, right? But some of you might think, Teacher Yonglam, can I use addition and multiplication principle to do this? Yes, right? So let's show the second method. What if I use addition and multiplication principle, right? So if we were to use this, you imagine, right? We have two identical digits, 2. I have a digit 3 and I have a digit 7. I want to find out how many ways are there to assign these 4 digits into the 4 seats differently. Okay, so over here, I have two identical digits 2, right? Placing them on the seats will be kind of tricky, right? Let's start with the rarer digits. Okay, so you might think, Teacher Yonglam, the rarest digit is 7. And you're right. How many ways can we choose the 7, right? Or rather, the position for 7, right? So step 1, let's choose the position for 7. Then there are 1, 2, 3, 4, right? Take note, it could be in any place value, right? So there are 4 choices. Okay, so now let's say I pick 7 here, very randomly, I pick it at the 10th place. Now there are 3 seats left, right? 3 possible places for the next digit. So let's take a look at the next digit. The next digit is 3. So step 2, we will consider the position for 3. How many choices are there for position 3? For the digit 3, right? So you have one choice, another choice, the third choice. So there are 3 possible choices for the position of digit 3. So there are 3 choices. Now let's say this time teacher Yonglam choose the thousandth place as the position for 3. Okay, now we have 2 seats left and the digits left will be 2 and 2, right? The 2 identical digits. No matter how I put them, it will always be 2 and 2, right? I could put these two, or these two, right? I can swap their order however I want, but they will give me the same 4-digit number. So either way, you are left with only one choice, right? To put the remaining digits, right? One way for the remaining digits only. So actually, your flexibility, your freedom in selecting the positions only come from the digits 7 and digit 3. You have 4 choices for the digit 7. And after selecting for the digit 7, the next thing you do, and then, right, you select the place for digit 3. So choose for digit 7 and then for digit 3. This we use the multiplication principle. 4 times 3, you will still get 12 as your answer, right? There are 12 possible 4-digit numbers. So this is a bit tricky because you have 2 identical digits, right? But thankfully, you can do using listing or you can use additional and multiplication principle. Okay, so that is the only MCQ in this paper that I would go through. Okay, so now let's move on to the next question, right? Similar to last week, we have another shortest path question today, right? Jovan was cycling from point A to his home at point B. He discovered that there were several ways to return to point B if he cycles northbound and eastbound only. That means the only directions that he can go will be going towards the north, right, in this direction, or towards the east in this direction. And he must start from point A. How many possible ways are there altogether? How many ways are there, right, to travel from point A to point B if you can only go north or go east? Okay, so this is similar to the question that I've gone through last week. So I'm just going to go through in brevity. Okay, so first you consider, right, the shortest path only. You can only move in the north or the eastward direction. So first, your starting point is here. Are there perhaps any points that you can visit only by going in one direction, right? These are what you call your one direction points, right? So step 1, of course, you have to find your one direction points. Okay, so from the starting point, for example, I can keep going to the east. I can keep going to the east to reach this point, and to the east to reach this point. There is only one shortest path to reach these points, right? So I'll indicate on the point 1, 1, 1 to show that, right, there is only one way to visit these points, namely by going towards the east. Likewise, you could also just start from the starting point A and go all the way northwards, right? I can go this way, this way, this way, right? All these points over here are one direction points. From my starting point, I can just visit these points by going through one direction only. So I can label 1 as well. Okay. Now, after labeling all the one direction points, we can label for the other points. Now, the key when you are labeling for the other points is always asking yourself, where can I come from? Right? What are the places that I visit, or rather I can come from prior to this new point? And we always go layer by layer from near the starting point to near the finish point. So maybe let's look at this layer first, right? We are done with the starting layer. Let's move on to here. For example, let's look at this point, right? So again, layer by layer, okay? So look at this point. How many ways can I reach this point, right? Where can I come from? I could come from this point, or I could come from this point, right? So there are two ways to reach this specific point, right? Which is by here or by here. Now I know there's one way to come here and then I continue. There's also one way to come here and then I continue. So in total, there are 1 plus 1, 2 ways. Okay? Now there are 2 ways to visit this point. Now let's look at this point next. Again, I can come from here or from here. Right? I have 2 ways to reach here, namely this and this, right? I have 2 ways to reach here. From these 2 ways, I can continue to come over here. Then from the bottom, I have 1 way to reach this point, then I can continue to go up. So in total, actually, I have 3 ways to visit this point, right? So you notice I add up, right? My key point is I add up the number of ways from previous points. This is the key that you need to notice or that you need to apply when you are doing shortest path question. Now let's move on to the next level. Okay, so this point can come from here, can come from here, right? 1 way plus 2 ways, right? So in total, there are 3 ways to reach this point. Then we look at this point, right? Can come here, can come here, right? So 3 plus 3, 6. Now this point is a bit special, right? Where are the points that I can come from prior to this point? You can realize that I can only reach this point by moving towards the right from this 6 over here. Right? So there are 6 ways to visit this point. Continuing from each of these 6 ways, I can move on to the right to reach this point. So if I have 6 ways to come here, from every way, I can continue to come here. That is why there are also 6 ways, right, to reach this point. Now this is tricky because there's only 1 point, right, coming before it. Now we are almost done. Let's look at the last level, right? Starting from here, right? 1 plus 3 is 4. Then 4 plus 6, this point, there are 10 ways. Finally, to reach B, 10 plus 6, there are 16 ways. So my answer is 16. All right. So here is another application of the shortest path question, which you can expect more in the next mock test as well. Okay. So yeah, that's how we do this question. Moving on, let's take a look at question 35. Right, this is one of the harder word problems. Let's read the question together. There are 3 numbers, A, B, and C. So let's list them down. A, B, and C. And you know that the sum of these numbers is 488. So you know A plus B plus C, their sum is 488. When you add 2 to A, subtract 2 from B, and divide C by 2, you will obtain the same answer. What is the value of C? Right, so you realize that even though you know the sum of A, B, and C, you don't know each of their numbers, right? What each of their value is. You only know what's the relationship between them, right? That relationship is their sum. And also, when you do something to each number, you will get the same answer. Namely, if you add 2 to the first number, you subtract 2 from the first number, the second number. And finally, when you divide by 2, right, from the third number. Repeat, add 2 to the first number, subtract 2 from the second number, and divide by 2, right, from the third number. You will get the same answer, right? But you don't know what is the same answer. Does that mean these 3 numbers, their sum is 488? No, this is the original number's sum. All right. So then can you form a relationship, right? Other than their sum? The other relationship you know is that the results after these operations are equal. So let's just give them a name. Let's just say that each of these numbers are 1 unit, 1 unit, 1 unit, right? So it's like your model, you have 1 bar, 1 bar, 1 bar. Okay, so let's see what will we do to each of these bars, right? If we work backwards to find the original number. Okay, so then this involves working backwards and a bit of model drawing. So let me just quickly draw a model first, right? To indicate what happens to the three numbers from after to before. Now we know that these three numbers at the end, they are the same, right? Which are 1 unit. So let me perhaps draw a 1 unit bar for each of them first, right? Of course, they will change, right? When we work backwards to get to the original number. Okay, so we know that each of them are sort of related to this same 1 unit. We just don't know what is this 1 unit, right? And what we do to them that leads to the final result being all 1 unit, 1 unit, 1 unit. But now it's time to work backwards. Let's look at the first number, right? You add 2 to it and you get 1 unit. If I work backwards, that means this number originally will be 2 less than 1 unit, right? 1 unit minus 2, right? That means your value A is actually not 1 unit, but you need to cut away 2 from it. You need to cut away 2 from it, right? And then, therefore, this part does not exist. Maybe I put across, or you can use dotted line. Okay, now this is for part A. Originally, it is 2 less than 1 unit. Now look at B, right? B, after you subtract 2 from it, you will get the 1 unit. That means originally, it is 2 more than your 1 unit. It's actually 1 unit plus 2. Okay, so that means originally, your B is not just 1 unit. You need to add an extra 2 behind it. Now C, after you divide by 2, you will get 1 unit. That means before that, it is double of 1 unit, which is 2 units. Right, so maybe instead of 1 unit, originally it is 2 units. Okay, so we all started from the end, right? We know that they are all 1 unit at the end. Then we work backwards to find out, right? Actually, they are not 1 unit at the start. They are 1 unit minus 2, right? 2 less than a unit, 2 more than a unit, and then double than a unit. Okay, each of them initially is like this. And now you have it, right? You have the original three numbers, how they look like. You also know their sum is 488. So now we can find out what the value of 1 unit is, right? So here, how many units are there in total? There's 1 unit in A, however, you need to subtract by 2, right? It's 2 less than a unit. So 1 unit minus 2. For B, it is 1 unit plus 2. For C, it is 2 units, and their sum is 488. Now, good news, right? You notice that there's a minus 2 and a plus 2, so you can cancel them out, right? They counterbalance each other. You are left with 1 unit plus 1 unit plus 2 unit equals 4 units, and 4 units equals 488. And then you can find your 1 unit, right? Your 1 unit is 488 divided by 4 equals 122. Okay, so the thing is, right, you know that 1 unit is 122, but the question is asking for C, right? So all you need to do now is realize that originally C is 2 units. So 2 units is 122 times 2 equals 244. And that is your answer as the initial value of C. All right. So this question is slightly more difficult. Not only do you have to do working backwards, you also need to realize, right? Since the result at the end is the same, you can link up the previous numbers, right, originally, by thinking in terms of units, working backwards, and express the process using a model. Yeah, it's definitely one of the more difficult questions. All right. Now with that, this is question 35, working backwards. Now we move on to another question, right? Question 36, which is actually a queuing problem and is quite similar to your SASMO question, right? If you have done your P3 SASMO 2025, it sort of looks like this, right? Let's read the question. A group of children are playing a game. They are standing in a circle, evenly spaced. Now this is very important, right? This means that if I can sit in even spaces, there might be chances where each child is sitting directly opposite someone else, right? In other words, you see here, the sixth child is directly opposite the 20th child. How many children are there in the group? Right. So if you follow the order 1, 2, 3, 4, 5, 6, 7, they go round by round, right, until the end, right? You go one full loop, you will realize at the end, the sixth child is directly opposite the 20th child. Perhaps it's a bit hard to notice like how it looks like. So let's just draw a picture, right? We have child number 6, which is directly opposite child number 20, right? So we just need to use this picture to figure out how many children are there in the group altogether. Now, just now teacher Yong Lam said, right, we follow the order 1, 2, 3, 4, 5, one loop all the way back to the start, right? We don't know how many children are there. We don't even know where the loop starts. But at least we know from the 6th to the 20th child, I will keep counting without missing anyone. Okay, so let's just list up or count which are the children that I should include in between the 6th and the 20th, right? So the 6th is the start. Before reaching the 20th, I will need to pass through the 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th. Now keep note, I'm not drawing according to scale, right? It's just, it might be a bit off, but most importantly is to list everything out, right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And finally, I will hit the 20th person, right? This is indeed a bit non-regular because even I cannot control the space, but it's okay. Just list, right? So now you realize 6 and the 20th, right? Between these children, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? In fact, you can just do 19 minus 7 plus 1. And you realize there are 13 children on the right. Now, if there are 13 children on the right, how about on the left? Where is your 1, 2, 3, 4, 5, right? Do I need to keep listing until I finish listing everything so that it makes sense? Well, you technically don't have to because I'm only asking, right, how many children are there altogether? Now, we have 13 children on the right. In order for them to be evenly spaced and these two kids to be right opposite each other, how many kids should be on the left? That's right, right? You don't need to list. You just need to know there are also 13 children on the left. Okay, 13 children altogether. Just so that it's balanced and there are the same number of children on both sides. They can sit directly opposite each other. So I have 13 children on the left plus 13 children on the right. But don't forget, 13 plus 13 does not include the 6th and the 20th child themselves. So you need to add another 2 to get the total number of children, which is 28, right? As long as you understand this problem and you are able to visualize it, you can understand that the left and the right, the situation should be the same, right? Same number of children, then you should be able to do this, right? It's slightly easier than your SASMO question, okay? Now, that relies a bit on your visualization. The next question, however, right, is pretty sweet and simple if you know how the method works, right? It's an addition and multiplication principle. Strictly speaking, I only need one step. Now let's look at this question. 6 girls and 7 boys are going to play a game. A team can only be made up of a boy and a girl. In how many ways can a team be formed, right? So first take note, in a team, right? I didn't mention that one is a group leader, one isn't, right? It's just a duo. So no matter I choose a boy or a girl first, it doesn't matter. As long as I choose one boy and one girl, then I'm done. Now, let's say I make this scenario a bit simpler, right? Let's say that I have 2 girls only, girl 1 and girl 2, and I have 3 boys, boy 1, boy 2, boy 3. How many ways can we form a team? Right, let me list them out. Girl 1 can form with boy 1, boy 2, or boy 3. So there are 3 ways to form such a team, right? A team can be formed by girl 1, boy 1, girl 1, boy 2, girl 1, boy 3, right? This is 3 ways. Right, now moving on. For girl 2 can also form a team with boy 1, boy 2, and boy 3, right? Maybe let's use a different color to make it clearer. Right, so girl 2 and boy 1 is another team. Girl 2, boy 2 is another team. Girl 2, boy 3 is another team. I have yet another 3 teams. So in total, I have matched every possible matching, right? Every girl matched with every boy. I consider the possibility. Altogether, there are 3 plus 3 equals to 6 teams that can be formed. But is there a faster way to get this 6 other than listing one by one? There actually is, right? So you see, I have 2 girls, right? So I select one girl out of these 2 girls. So 2. Every girl that I selected, there are 3 ways to form a team with a boy, right? Every girl I selected, there are 3 ways to choose the boy for it, right? So 2 times 3. In fact, the 2 times 3 come from 3 ways, starting from girl 1, 3 ways, starting from girl 2, right? So there are 2 times 3. That's how you get 6 ways in total to form this team with one boy and one girl. Okay, so this is what we call the multiplication principle, right? I choose one item from one category, the girls, and then I choose another item from the other category, the boys, right? So this 2 times 3 equals 6 is strictly speaking the only step you need for this question. Okay, and then yeah, now I change the question to 6 girls and 7 boys. So by the multiplication principle, there are 6 ways to choose a girl. Every time we choose a girl, there are 7 ways to choose a boy to pair up with this girl. So choose a girl 6 ways, then choose a boy 7 ways. 6 times 7 equals 42 ways, right? And that is the only step you need for this question. It's actually not that hard, right? You just need to understand, right, that I'm choosing one category and then the next category. Choosing one and then the next guarantees that you need to use the multiplication sign. All right, and that's question 37. Pretty simple, actually. Okay, so this is actually a key lesson that we will go through in our upcoming Math High Achiever classes. So do keep a lookout for that if you are interested. Now let's take a look at question 46, right? Yet another listing question, right? I noticed that a lot of you might still need some guidance when it comes to listing in order, right? So I'll prepare more practices on that. Now let's look at this question. 11 can be written as the sum of 3 different positive whole numbers. Take note, I must write it as the sum of 3 different positive whole numbers. Positive means I cannot have 0. So things like 0 plus 1 plus 10 doesn't make sense. Second, the 3 numbers must be different. So can I say 11 equals to 1 plus 1 plus 9? No, because I have repeated 1 2 times. I cannot use the same number when forming the sum. So here's an example that the question gave you. 11 equals 1 plus 2 plus 8. Now, how many ways, including this way, by the way, right, can we write 11 as the sum of 3 different positive whole numbers? All right, so when we do the listing, right, take note, what counts as a repeated way? What counts as a new way? So when I say sum of the numbers, the order of the numbers actually do not matter, right? 1 plus 2 plus 8 could be the same as 1 plus 8 plus 2, right? 2 plus 1 plus 8, 8 plus 2 plus 1. They are all the same actually, right? Unless the question specifically says, okay, maybe like I'm giving these numbers to 3 different people. So you receiving a 1 might be different from me receiving a 1. But if I'm simply saying I'm writing it as 3 different positive whole numbers, sum, the combination, meaning the numbers that I choose matter, but the order that I arrange them do not matter. So I'm finding how many ways can I split 11 differently into 3 different positive whole numbers? Different order counts as one same way. So I cannot repeat these. I can only keep 1 plus 2 plus 8. Right. So to list out all the possible ways to write the sum, all I need to do is to list in order. Right. List. Let me write it out. List in order. In particular, right, the question gave you an example which lists the numbers from small to big, which is what I'm going to do as well, right? I'm going to list out the digits in ascending order, starting from a small number to a big number. So if you realize that suddenly the numbers are out of order, then most likely it refers to a repeat. Okay, so let's start from the smallest possible first number, which is 1. Now, of course, 1 plus 2 plus 8 is an example. Now, what's the next example? 1 plus what? Now, I tried 1 plus 2. Of course, I can't do 1 plus 1. Now, when we list in order, we try to list from small to big, right? So after 2, the next smallest number I can consider is 3. 1 plus 3 plus 7, right? Please take note, you could list properly, but your calculation should also be correct, right? A hint here is whenever you plus 1 here, actually to counterbalance, you need to minus 1 on the other side. Okay, so the next one will be 1 plus, continue to plus 1, 4, the next number plus 6, right? You can check, right? 1 plus 4 plus 6 really is 11. Check along the way. Next, maybe we can try 1 plus 5 plus, it's a 5. The numbers repeat, so I cannot consider this case. And the next one will be 1 plus 6 plus 4. Now, do you notice something? It's the same three numbers, just in a different order, right? I already considered 1, 4, and 6. So 1, 6, 4 is a repeat. I don't need to consider this, right? In fact, the numbers are not listed in ascending order. So I can just stop here, right? Anything beyond 1 plus 7 plus 3, all these will be repeats. All right. Now, you might want to stop here, but please take note, the smallest number may not even be 1, right? It could be 2, for example. So let's consider what happens if I have 2 plus something plus something. Now, because the numbers have to be different, I cannot choose 2 again. And of course, I cannot choose 1 again, right? I need to list in order, ascendingly, small to big. So the smallest number that I can consider from is 3. 2 plus 3 plus 6 is 11. That's correct. So you see, I found another way. Now, all I need to do is to keep listing, right? The next one, 2 plus 4 plus 5. Another way. The next one, 2 plus 5 plus 4. Right, you realize we have started to meet repeats, right? The numbers are not in ascending order, right? It's like this. So at this point, there's actually no need to continue, right? Once we found a repeat, we can just stop here. You can continue listing beyond, and you realize there won't be any other valid cases. All right, now let's not give up, right? What if the first number is 3? Now, if the first number is 3, the next number must be different from it and also in ascending order. So maybe I'll try 3 plus 4. The last number you need to add to it is 4. Now I start from 3 and immediately I have a repeated case, right? 4 and 4, they are repeats of each other. So I don't need to consider this, right? This is invalid, get out. And I actually don't need to consider beyond this, right? The first number cannot be 3 or bigger because then it is impossible to find a new combination of 3 numbers in ascending order that add up to 11, right? Even 3 cannot give me another case. So don't think about 4, 5, 6. All right. So with that, how many ways have we listed? 1, 2, 3, 4, 5. So in total, there are 5 ways. Okay. So it's just this listing method, right? Most importantly, list in order. Always check your question for all the conditions needed. Okay. Now with that, let's take a look at 47, right? This is a age problem. It's actually not that difficult. All right, let's try together. This year, Elizabeth is 8 years old. So I directly give you Elizabeth is 8 years old. And her mother is 4 more than 4 times her age. Now, some of you might be very excited. You want to draw the model right away. Right. Now, let's continue reading the question first. When the sum of their ages is 60, how old will her mother be? Right. So this is a age problem, but technically speaking, you don't need to draw a model to do this. Why? Because in normal age problems, the generic ones that you perhaps see on your HAL book or whatever, right? They are all giving you some difference and multiple information, and you don't know any of their ages individually. However, this question is actually pretty simple. I straight up told you this year Elizabeth is 8 years old. Now, how old is her mother? Her mother is 4 more than 4 times her age, right? So this is an understanding of multiples. 4 more than 4 times means on top of multiplying the age by 4, I also add 4 to the ages after that, right? The multiple relationship comes first. So 4 times and then four more. So how old is the mother? The mother is 4 times 8, right? 4 times of Elizabeth's age, and then four more. So you need to plus four. 4 times her age and four more. Directly calculated, you will get that her mother is 36 years old this year. Right? This is their ages this year. Right. Now, we are now curious about their age sum because we want the age sum to reach 60. What is the current age sum? The current age sum, right? Current age sum is 8 plus 36 equals to 44. Right. So this is their current age sum. Okay. So the current age sum is 44, right? But we want their age sum to be 60. Does that mean 60 minus 44 equals 16 years have passed? Right? This is a common track point for most of the people here, right? Because let's see what happens when they grow older and older. Right? This year, their age sum is 44. But let's say, what is their age sum 1 year later? 1 year later, Elizabeth will be 8 plus 1. Oh, it's lagging a bit. Okay, let's wait for a moment. Elizabeth's age 1 year later will be 8 plus 1 equals 9. And the mother's age 1 year later will be 36 plus 1 equals 37. Right, so you will notice that actually both of them will grow old at the same time. And in just 1 year, the sum will increase by how many? Right, their new sum is 46. The increase will be by 2. Now, the reason is simple. That's because in 1 year, right, Elizabeth grow old, mother also grow old. They both grow old together. So the age sum of two people will actually increase by 2 every single year. So from 44 to 60, right, which is our target age sum, how many years have actually passed? First, we find out, right, what's the total increase in the age sum. The total increase is 60 minus 44 equals 16. But do take note, every 1 year, the age sum increases by 2. Every 1 year increase by 2. Every 1 year increase by 2. How many such every 1 year increase by 2 do you need to get an age sum of 16 increasing? Right? So that will be 16 divided by 2, right? Every year plus 2, every year plus 2. It will take you 8 years, right? So that you can reach the desired age sum. So that means it will be 8 years later for both of them. This year, the mother is 36 years old. So 8 years later, the mom's age will be 36 plus 8 equals 44 years old, right? So my answer is 44 years old, right? The wording here, four more than 4 times, is just there to intimidate you, but actually it's pretty straightforward. The key point here is number one, how to correctly find the mother's age this year. Second, two people, their age sum will increase by 2 every single year. Because I grow old by 1, you also grow old by 1 every year. All right. And yeah, that's it for the entire video, right? I have selected all the questions that are marked in red to go through in this video. Hopefully it has been helpful, right? And I will see you in the next mock test explanation video. Okay? Thank you so much, and I'll see you when I see you again. Bye bye.